In this lecture, we will talk about modulus and argument, which is also called as amplitude. So what is a modulus of a complex number z? So if z is equals to x plus iy, modulus of z is nothing but square root of x square plus y square. Please be careful, it is only a square of a real part and imaginary part. We are not taking I here or I square here. So just take care of that. So what is the modulus of z? It is nothing but a square root of x square plus y square. Then there is another term that is called as argument or amplitude. So argument and amplitude is nothing but angle theta. So what is this angle theta? So this angle theta is angle of this complex number z is equals to x plus iy measured from the positive real axis. So theta is an angle between z and positive real axis. So here theta we can define using this tan inverse of y by x. So the value of theta is tan inverse of y by x. Remember one thing, we are measuring theta from the positive real axis. Let us see graphically what it is exactly. So in this graph now, this is the point z or the complex number z is equals to x plus iy. Now let us draw a line joining origin and z is equals to x plus iy. So this is the complex number z is equals to x plus iy. This is nothing but the Argand diagram of the complex number z is equals to x plus I. So now in this diagram, this length of z from the origin is nothing but our modulus, and the angle theta is nothing but this angle, which I will mention by this. This is theta. Now from this, what is this length? Well, let us first find out the value or the distance, or what will be the distance between the point z and 0. Z is equals to x plus iy is nothing but coordinate wise x comma y. So in this case, what will be the distance between 0 and x comma y? So using Pythagoras theorem, you can also find out that distance. Let us call for the time being that distance as r. So suppose this distance is r. So what is r in this case? So here r is nothing but square root of x square plus y square by Pythagoras. Then we know that this angle is 90 degree. Then just using simple trigonometry or using trigonometric function, we can find out here what is cos theta and sin theta. So clearly cos theta is x by r and sin theta is y by r. So x is equals to r cos theta, y is equals to r sin theta. If I calculate tan theta, it will be clearly y by x. So just because of that, we're getting theta is equals to tan inverse of y by x. And r is over here nothing but the modulus of z. That is nothing but the distance of the point x comma y from the origin. So modulus of z is nothing but distance of z from origin. And as it is distance, it is always positive. And always remember the modulus of z we can also denote by small r. So we have seen here two definitions, that modulus of z is nothing but square root of x square plus y square, which is also called as r. And another definition, that is argument or amplitude, theta is nothing but tan inverse of y by x. Now every time it is not possible to find out theta using the definition that we have seen, because while finding angle theta for z is equals to number which is in the form of a plus ib, and the number z is equals to minus a minus ib, because in both the cases your theta will be tan inverse of b by a. But obviously if you write this angle theta for z is equals to minus a minus ib as well, you will get a wrong answer. To avoid all this, we will use one thing here. Whatever is the value of z, we will first find out what is alpha. So alpha is nothing but tan inverse of modulus of y by x. Depending on the complex number x plus iy and the value of alpha, we will find out the value of theta here. So suppose z is equals to x plus iy is a number where x and y both are positive. So suppose x and y both are positive, then obviously the number belongs to first quadrant. Okay, this is the first quadrant, this one is the second quadrant, this is third quadrant, this is fourth quadrant. So if number belongs to first quadrant, whenever x and y both are positive, so this is z is equals to x plus iy. So now let us see what is angle alpha and theta So here clearly this is alpha, and as we are in the first quadrant, alpha and theta both are same. Always remember theta is the angle measured from the positive real axis. So in this case, when we are in the first quadrant, theta and alpha both are same. So I'll mention that theta is equals to alpha in the first quadrant. If my number belongs to second quadrant, x is negative and y is positive. So here we will have x is less than 0 and y is greater than 0. So in this case, let us see what will be theta and alpha. So this is z is equals to x plus iy. Now in this case, what will happen? The angle alpha will be this. This is alpha. But we are interested in the angle theta. So angle theta is the angle which we are measuring from the positive real axis. So this is the angle theta. So clearly, as we know alpha, we know this full angle which is pi. Just because of that, in the second quadrant, theta is equals to pi minus alpha. Obviously, it is a lesser than 180 degree. So just because of that, theta is pi minus alpha. Let's see what will happen if the number belongs to third quadrant. So whenever the number is in third quadrant, so suppose this is z. So in third quadrant, x is less than 0. Also, y is less than 0. X and y both are negative in the third quadrant. So this is the value z. Let's see what is alpha and theta. So here in this case, this is alpha. So here this is the angle theta. So therefore here theta is nothing but pi plus alpha, because you can clearly see that here theta is bigger than 180. So theta is nothing but pi plus alpha. Now let us see what will happen if the number is in the fourth quadrant. Now in the fourth quadrant, x is greater than 0 but y is less than 0. Let's see what will happen with the angle if the number is in fourth quadrant. So this is z is equals to x plus iy. Now in this case, this value is alpha. Now remember one thing, we are measuring theta from the positive real axis. So either we are measuring in clockwise or anti-clockwise direction, that doesn't matter. So in this case, as we are measuring the angle theta in the opposite direction, so therefore theta is nothing but minus alpha. Here also you can measure theta in fourth quadrant in this way, that is 2 pi minus alpha, but preferably we will use theta is equals to minus alpha. So this is the way we can measure the angle. Let us see now some examples where we will find out r as well as theta. Now here, in all cases, x is either 1 or minus 1. Similarly, in all cases, y is either 1 or minus 1. We know that the definition of r is nothing but modulus of z, which is nothing but square root of x square plus y square. So here in the first case, we will have square root of x square plus y square as 1 square plus 1 square. That is square root of 1 plus 1, which is nothing but square root of 2. In second case also, minus 1 square is 1 and 1 square is 1, so we will get 1 plus 1, that is square root of 2. Here again we will have x as minus 1 squared, y as also minus 1 square, but which is nothing but square root of 1 plus 1, that is nothing but square root of 2. For 1 minus I, we will have modulus of z as 1 square plus minus 1 square, which is nothing but square root of 1 plus 1, which is nothing but square root of 2. Can you see that in all cases we are getting r as square root of 2 only, because the number 1 plus I minus 1 plus I minus 1 minus I 1 minus I, all numbers are at same distance from the origin, and just because of that we are getting r same. So r is square root of 2 in all cases. Let us see what will be the angle theta. Now while finding angle theta, we are not going to use direct definition. First we will find out alpha. So for z, let us try to find out alpha here. So in this case, alpha is equals to tan inverse of mod of y by x. So we know that this is tan inverse of modulus of y by x. So modulus of y by x will always give us the positive answer. So either we have plus 1 or minus 1. So I'll mention here, either we have plus 1 minus 1 here, as well as whenever x is either plus 1 or minus 1, that doesn't matter, we will get the same answer, which is tan inverse of 1, and tan inverse of 1 is pi by 4. So in all cases we will get alpha as tan inverse of 1, because we are taking modulus here. So modulus of 1 upon minus 1 is 1, modulus of minus 1 upon minus 1 is again 1, modulus of minus 1 upon 1, that will be again turn out to be 1. So let us check now the angle theta, depending on the method that we have seen earlier. So the complex number 1 plus I is in the first quadrant, and just because of that, here theta is same as alpha. So theta is equals to alpha, which is nothing but pi by 4. The number minus 1 plus I is in the second quadrant, where theta is pi minus alpha. That's why the value is pi minus pi by 4, and therefore the answer of this is 3 pi by 4. The number minus 1 minus I is in third quadrant, where theta is equals to pi plus alpha. Therefore the angle theta is pi plus pi by 4, which is nothing but 5 pi by 4. Similarly, 1 minus I, this number belongs to fourth quadrant, where theta is nothing but minus alpha, and just because of that, here the angle theta is minus pi by 4. So this is the way we can find out the angle. Let us see some properties of modulus and amplitude. We will first see the properties of modulus. So modulus of z and modulus of z bar and modulus of minus z will be always same, just because z, z bar, minus z, all these numbers are at the same distance from the origin. We know what is modulus of z. Modulus of z is nothing but square root of x square plus y square, which is nothing but the distance of z from the origin. Z into z bar, suppose z is x plus iy, and z bar, which is nothing but the conjugate of z, which will be x minus iy. The value of x plus iy into x minus iy is nothing but x square minus I square y square. I'm using here the formula a minus b, a plus b, it is nothing but a square minus b square. So the value of this is x square plus y square, because we know that I square is nothing but minus 1. This is clearly modulus of z square, as we know that mod z is square root of x square plus y square. If we take a square of modulus, we will get x square plus y square. Modulus of z1 into z2 is modulus of z1 into modulus of z2. We can distribute modulus on multiplication, as well as we can distribute modulus on division. So modulus of z1 upon z2 is nothing but mod z1 upon modulus of z2. Obviously z2 is not equal to 0. Modulus of z is 0 if and only if z is equal to 0. Now let us see some properties of amplitude and argument. Argument of z1 into z2 is obviously argument of z1 plus argument of z2. Argument of z1 upon z2 is argument of z1 minus argument of z2. Thank you.